Hello there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vandibona, and from this episode we are talking about creating object references. You already know that Java cares about type. It won't let you to do something bizarre and dangerous, like the stuff shown in here, putting a giraffe reference into a rabbit variable. What would happen when someone calls the rabbit to hop? Total weird situation. So don't expect the compiler would compile this statement in here. Now let's talk about more on this, because this is a top priority important matter in object orientation. Therefore, you need to get a good understanding on this thing. We already discussed about the primitive variables in a previous episode. Now, what about the non-primitive variables? Actually, there is no such a thing as object variables. There is only an object reference variable. So, from this episode, we are talking about object references. An object reference variable holds bits that represent a way to access an object. It doesn't hold the object itself, but it holds something like a pointer or an address. In Java, we don't really know what is inside a reference variable. We do know that whatever it is, it represents one and only one object. And JVM knows how to use the reference to get that object. In Java, you cannot stuff an object into a variable. As you already know, in primitive variable is full of bits representing the actual value of the variable. But object reference variable is full of bits representing a way to get the object. Remember how you used the dot operator? You use the dot operator on a reference variable to say, use the thing before the dot to get the thing after the dot. For example, let's take this object D created from the class dog. Now this d.bark means use the object referenced by the variable D to invoke the bark method. When you use the dot operator on an object reference variable, think of it like pressing a button on the remote control of that object. Now think an object reference is just another variable value, something that goes in a cup. And this time the value is a remote control. So that is the difference between primitive variables and object reference variables. Here is a good illustration to show you the difference between primitives and references. In the primitive variable section, it declares a variable x with the data type byte and initialize it with the value 7. Now the cup get hold of the bits representing the value 7, which includes 0, 0, 0, 0, 0, 1, 1, 1. Now for the object references, it's a whole new story. First of all, let me tell you the 3 steps of object declaration, creation and the assignment. From this part, it declares a reference variable. This tells the JVM to allocate space for a reference variable and names that variable my dog. So the reference variable is forever of type dog. In other words, a remote control that has buttons to control any dog, but not cats. From this part, it creates an object. It tells the JVM to allocate space for a new dog object on the heap. We will later get into know what is this word heap means. From this part, it links the object and the reference. So it assigns the new dog to the reference variable my dog. In other words, program the remote control. So for a reference variable, the reference value is the bits representing a way to get to the dog object. So in primitive variables, the value of the variable is the value itself, but in the reference variables, the value of the variable is the bits representing a way to get to the specific object. Hope you got a good understanding on primitive variables and reference variables, the difference between these two. Now here is a frequently asked question by most of the people. How big is a reference variable? As you already know, in primitive variables, we categorize several types depending on the size. In type, byte type, long type, short type, likewise. So in reference variables, are there any such kind of a thing? Now the answer is, you really do not need to care how much big the reference variable is. But when it comes to memory allocation issues, your big concern should be about how many objects you are creating. And now with that answer, you would surely ask whether all object references are the same size. Well, actually, yes, all references for a given JVM will be the same size, regardless of the objects they are referencing. But each JVM might have a different way of representing references. So, references on one JVM may be smaller or larger than references on other JVMs. Now I'm going to talk about the thing that I had earlier promised, the heap. Each time an object is created in Java, it goes into an area of memory called as heap. No matter when, where or how they are created, all objects are live on this heap. The Java heap is actually called as garbage collectible heap. When you create an object, Java allocates memory space on the heap according to how much the particular object needs. An object with, say, 15 instance variables will probably need more space than an object with only 2 instance variables. When we're talking about Java, we cannot avoid talking about the memory because Java manages the memory for you. When JVM can see that an object can never be used again, that object becomes eligible for something called as garbage collection. And if you are running low on memory, the garbage collector will run and throw out the unreachable objects and free up the space so that the space can be reused. Let's understand this process using illustrations. In the first step, we declared 2 book reference variables and created 2 new book objects and assigned the book objects to the reference variables. So the 2 book objects are now living on the heap. We had labeled them 1 and 2, and the B got the bits saying where the 1 is living, and the C got the bits saying where the 2 is living. In the second step, we declare a new book reference variable D, and rather than creating a new third book object, we assign the value of the variable C to the variable D. Now what does this mean? It's like saying, take the bits in C, make a copy of them and stick that copy into the D. And now remember, the bits in C says where the object 2 is living. So now both the C and D is refer to the same object. It is same as having 2 remote controls programmed to one TV. Now in the third step, we assign the value of the variable B to the variable C. By now, you should know what this means. This means the bits inside the variable B, which means the bits that says where the object 1 is living. So these bits are copied and this copy is sticked into the variable C. Now both the B and C refers to the same object. And now let's look at a garbage collection scenario. In the first step, we declared 2 book reference variables, create 2 new book objects and assign the book objects to the reference variables. So 2 book objects are now living in the heap. In the second step, we assign the value of the variable C to the variable B. The bits inside the variable C are now copied and the new copy is stuffed into the variable B. Therefore, both variables hold the identical values and they are referring to the same object. And here you can see the object 1 is abandoned because it has no more references and it's unreachable and eligible for the garbage collection. Therefore, at some point when your memory is low, the garbage collector will collect this object 1 and gives you free space. Now in the third step, we assign the value null to the variable C. This makes the C a null reference, meaning it doesn't refer to anything, but it's still a reference variable. And another book object can still be assigned to it. So not like the book object 1, this reference variable will be still remained. And you can use it later. Now look at the book object 2. Even though it loses the initial reference, the reference variable C, it still got an active reference, the reference variable b. As long as the reference variable b refers the book object to, it is not eligible for garbage collection. The next thing we are going to discuss about is arrays. Arrays with object, because in a previous episode we showed you how to create arrays with primitive variables. So this time it's about objects. Arrays with objects. The first step is to declare a dog array variable, and here we declare the dog array variable pets. And the second step is to create a new dog array with a length of 7 and assign it to the previously declared dog array variable pets. So in this point we have an array of dog references but no actual dog objects yet. In the third step we create new dog objects and assign them to the array elements. And remember, elements in a dog array are just dog reference variables, but we still need dogs. In all the previous episodes we accessed the dog's instance variables and methods using the dot operator. But in this array, how can we access the instance variables and methods? Because in the dog array we don't have an actual variable name like as this Fido. So what is the solution? Even though in the array we don't have any variable naming for a specific object, we can use the index position of the object. So it is something like shown in here. And always remember we use square brackets to put the index number, and always any array starts with the index number 0. Now before winding up this episode, I want to say something that you have to always remember. Java cares about type. Once you have declared an array, you can't put anything in it except the things that are of the declared array type. For example, you can't put a cat into a dog array, like as you can't put a double into a int array. Remember, we learned that when creating primitive arrays. So the compiler won't let you to put a wrong thing in an array based on the array's declared type. And that's all what we got here in this episode. From the next lecture, we are trying to do some few activities, questions to stick this thing more into your head. So thank you for watching and stay tuned on. This video brought to you by edupediaworld.com. Watch more from our website.